Something I just forgot to mention yesterday that I'd like to just bring to your attention now. Let me just share my screen really quick here. So I'm going to share my screen. If you would take a look at Blackboard real quick. So, the YouTube playlist before today had specific dates on the videos. And what happened was I had to like copy over some videos from another playlist I had, and I wasn't able to change the names, and so I wasn't able to like add titles to them and put dates on them. And so the way I've been labeling them is if you go to online lectures here on Blackboard, and it's got the sort of the video you should be watching every day, and in the title it sort of tells you what you should be doing for that day. So, for today, for example, you should have watched the first half of the trig identities video. So the trig identities video is, a pretty long video, and some of them are a little bit longer. And so if they're a little bit longer, then we might just break it up into two pieces. Like the next, on next Tuesday and Thursday, we're going to split up the trig formulas video between two sessions. And you're doing this all on your own, sort of on your own pace anyway, and so you can watch all the videos you want whenever you want. So I'm just trying to break it up in a way that I think makes sense in terms of like class time and the time that we had committed to class time. And you can obviously make your own schedule if whatever works for you. So I meant to mention that last time when there were some questions, and so I just thought I'd mention that to everyone first. Let's see here. Let me turn this light on. So I don't really have any other announcements or anything. It looks like most people are staying on task and completing the homework, and I appreciate the questions you guys come here with. There weren't any homework questions via email this time, but does anyone have anything particular they want to talk about? Or do you want me to say something about trig identities?
Will these identities be on the test?
So the test, the next test we're going to have, which is going to be on, what did I say yesterday? The 23rd, I believe. Let me double check the date. Yeah, Thursday the 23rd. Let me stop presenting here. Sorry. Forgot I was still presenting. We're going to have our test on Thursday the 23rd, and it's going to be on all of trigonometry. And so actually, let me present one more time. I should have just stuck presenting. I posted a whole bunch of review material that you can start looking at whenever you want. So if you go to course documents and then test topics and solutions and practice problems, there's test 2 topics here. It's all the trig topics. There's some review problems. There's the solutions to those problems. And then there's a whole bunch of trig identities for you to practice if you want them. But if you're just looking for the topics, they're in that folder, and there they are. And so it's all the trig things. It's everything from trig. And so yes, trig identities are one of those things. And so the way trig identities work, let me just maybe summarize really quick. I'm not going to say too much, but because we're going to be looking at them sort of for a while. And so I know they're one of the harder things that people often encounter in trig, and they can really confuse people. But sort of the general idea is, and I give the identities on tests, let me say that, this is one of the things I put on tests, and it's not something you need to memorize. Okay, so I put like this table on the test, for example. And so the idea is it's a way we can relate the different trig functions. And then what we can do is we can show that one trig function or some combination of trig functions really equals some other combination. For example, just the first example here was, it turns out that tangent times cosecant, when you change it to sines and cosines and simplify, is really just secant. And so, the idea is if you had these two things in an equation, you might just want to replace it with secant because that's a simpler thing to work with, right? It's like one thing instead of two things. So that's sort of the general idea, but it's a lot of substitution and algebra and like simplifying things. And I know people get confused by it because it's not something that like has an algorithm to it. It takes a little bit of creativity sometimes. And so you really do need to like get your hands dirty and try some of these. Don't be scared of it, especially, this is the kind of thing I ask people to do in class a lot, is we work on these things in groups, and I ask you guys to, try some while I'm there and things, and I'm not able to do that now, right? And so I do that in the video a little bit, and I would really encourage you to when you're watching the video, if I say, hey, try this one, to actually try that. So anyway, I see Gabe had a question. Can we go over evaluate sine inverse of -1 or 1? and finding period from an equation. Sure. So let me just mention to you that my back is like really hurting badly. I'm actually, you laugh at me if you saw me trying to sit in my chair right now. And I'm just telling you that because I'd like to keep this relatively short, and I may have to bail at some point if I just can't handle it, to be perfectly honest. So anyway, yeah, let's talk about those though. So let's look at the first one you said. Let me double check what you wrote again. Was it sine inverse or sine? So it was sine of sine inverse of 1. Let me grab the notes from that section just so I can point it out to you where you might want to look at this. So this is on page, it's in obviously the inverse section, and it's on page, I think, 55. And so we would want to use this concept for there. And this particular problem, because the inverse is on the inside, that looks like the top one. And so this says that if you have the sine inverse inside of sine, let me zoom in on that so maybe in case you're on a phone or something. This property says if you have sine inverse inside of sine, then those two things will cancel out, and whatever is inside sine inverse is the answer, as long as the x is between -1 and 1. And so in this particular problem, we have that situation, right? So here's the problem. Sine of sine inverse of 1. 1 is between -1 and 1, right? So 1 is in the interval -1 to 1. And so that means sine and the sine inverse just cancel out, is what that property tells us. Oops, I forgot I was zoomed in, sorry. So 1 is in the correct interval, right? That's the way you do those problems, is like you check to see if you're on the right interval, and if you are, the things just cancel, and that's the answer. And so in this case, you are on the correct interval, and so those two things just cancel out, and then this just equals the number 1. So something specific you wanted me to clarify about that one, Gabe, or anyone else, before we talk about the other question? Okay, that answers it for him. Other thoughts from anyone else about that? His other question was about finding the period from an equation. Let me start pulling those notes out, see if anyone else has another question here. So this is obviously from the graphing section, which I am having a hard time finding for some reason. Here it is. So in the graphing section, the period, remember, was how long it takes the graph to repeat itself. So the question here that Gabe asked in the chat was, how do you find out the period from a graph? I mean, from an equation. I'll answer your question one second, Cameron. So the period is how long it takes the graph to repeat itself. And so on this picture here, this was one period because that's like one copy of the graph. This would be another period because that's another copy. And then it just keeps repeating itself over and over again, right? And so you can see that's like the width of the graph. And so the width of the graph is controlled by horizontal compression or stretching, right? Like if you took a graph and you stretched it or compressed it, that's going to change the width, which is going to change the period. And so we know that the k inside these functions, the thing that's multiplying the x, is what controls the width, that does the horizontal stretching and shrinking. And so that's why for the period, you do 2 pi divided by whatever k is. Because normally the period's just 2 pi, and then k will either stretch or shrink it out, depending on what that is. So like in an example on this page, let's see here. This one had a k value of 4, right? So it was 2 minus 3 times sine of 4 minus 4 times x minus pi. And so the thing multiplying the x is 4, and so k is 4. And so when we were doing the period in that one, you take k and you just divide it into the 2 pi. And so in this case, it would be 2 pi over 4, and that reduces to pi over 2. And so you're messing around with the k value, and you divide it into 2 pi for the period. The question that Cameron asked was, will the identities be on the exam? And the answer is yes, the identities will be on the exam. And I am also so basically what I'm thinking for this exam, I'm probably going to let you use a note sheet for I'll let you use more than likely some sort of note sheet for the final. But for this trig exam, like some of the questions I want to ask are things like I'm going to ask things like what's sine of pi over 6, right? And so that involves like finding pi over 6 on the unit circle. You find the x and the y value, right? The y value is the answer. And so if I let you like bring in notes and stuff, this would be a stupid problem because you would just have sine of pi over 6 somewhere in there, and I wouldn't be able to tell whether or not you knew how to do it, basically, right? And so what I do for these trig tests is I give you lots and lots of reference material, but not let you necessarily bring in notes because again, I want to see that you know how to use the unit circle and that you know how to like evaluate the trig functions without just using a calculator or without just seeing the answer on a piece of paper. And so let me show you the things I usually give on tests, and I think that that'll give you an idea of what you need to study. And I should post this. I was actually thinking about how I need to post this on Blackboard to show you what I give on tests. So let me open it up here. And I'll share my screen and show you. All right, I'm going to share my screen again and show you what I usually give on tests. So this is the reference material that I usually give. That's not working. Sorry, I need to redo that. Is it just, that's not what I want to show. What is it presenting? Oh, that is what I want to show. Okay. So if you're looking at my shared screen, these are the equations and the formulas that I put on trig tests. And I'll put this on Blackboard. Let me run through it. I give you the first half of the unit, or the first quadrant of the unit circle, and so I give you all the reference points. I give you a blank unit circle just to play around with. I give you the identities that you need to know. I'm sorry, this is box number 1. So this is like how you evaluate trig functions. So I give you box number 1. I give you the trig identities. I give you the addition subtraction formulas. I give you the double angle formulas. I give you the half angle formula. So basically, I give you like a lot of the boxes throughout the chapter that you need. So there's not a lot of memorizing of formulas. You need to know how to use the unit circle. You need to know how to relate it to box number 1, right? Like giving you box number 1 is almost like, I feel like, too much because I don't know, maybe that's too much information. You should probably know those things. You should probably be able to memorize those. But anyway, this is what I give you. So I think this is usually more than enough to alleviate like memorizing everything that feeling like, oh, there's so much stuff to memorize. Yeah, there's a lot of stuff you need to know, but I'm giving you most of it. You need to know how to like relate them to each other and use it, basically, right? So I'll go ahead and post this. I'll post those 2 pages along with the test topics and practice problems, so you can have that to reference. What else? What else do you guys like to talk about? Other thoughts, other questions, other things you're thinking about related to the tests? I'm going to stop sharing my screen here. Other questions about the homework? Were there questions from the homework last night that people weren't able to get that they want to see an answer to or anything like that? Just going to pause a minute and let anyone type anything or say anything they want to say. And I'm going to be posting that thing online while I wait here. Okay, so I just posted those formulas, those 2 pages I just showed you on Blackboard. It says test 3 reference material just because I took it from last year's class, my test 3 from last year. Anyway, it's the same reference material, so you'll have an idea of what you get for the test. Anything else? I'm happy to keep talking here. I'd love to make these times useful for you in any way I can, but if that's all you got, I'm in a lot of pain, so I'm gonna sign off if no one has any other questions. All right, thanks guys. Have a good weekend. I'll see you on Monday, or you'll listen to me on Monday or whatever.